How crazy did this sound? You're a big time developer with a popular product and you've got a lot of customers. And some customers are having a hard time using your software. It's crashing, it's doing weird stuff. You don't even know. It's a bad situation, and it's not a situation that's even on your radar. Does that sound far fetched if you're a giant multinational corporation? Well, that's exactly what happened in 2023 with Intel and their 13th and 14th gen CPUs. Gamers were experiencing a lot of issues. I mean, Epic Games and many other companies posted about that. I was looking into it. And I knew that something was wrong, but how did I know? It was the data. And that was one of my secret weapons for gathering data was Sentry. Sentry isn't just an application monitoring platform. For my purposes, the way I see it, I've weaponized logging up and down the stack in order to close the loop logging client, server, and everything in between. So today's video is very special for me. Sentry has actually agreed to be here with me so they can explain a little bit more about their platform, and I can explain a little bit more about my thought process and how their product was instrumental, pun intended, in helping me piece together what was going on when I was doing my research about game crashes and everything that was going on with the Intel CPUs. So I'm joined here with Amir from Sentry. Let's get to it. Tell us a little bit more.
Hey, thanks for having me here. A short intro from my side. My name is Amir. I'm a software engineer at Sentry, working mainly on the game dev experience team. So yeah, I have quite some experience with GPUs and CPUs and all of the fun stuff that we are going to talk about today.
Give us the 5 minute rundown, Amir. Like, okay, here's Sentry. I wanna integrate Sentry into my thing. Like, is this just for games, applications? Like, how does it work?
Yeah, so Sentry is everywhere. So Sentry is application monitoring software, as you said, and we have over 100 SDKs. And Sentry started quite some time ago as a basic error monitoring platform that was expanded into performance monitoring, tracing, session replays, log, AI debugging, all of the nice tools that us software developers like to use these days. So it's not just gaming. Gaming is a quite new investment and is something that very well integrates into the ecosystem of Sentry. So for game developers using Unreal, Unity, Godot, or even custom engines, Sentry offers SDKs for integration, but not just for PC or mobile, also for gaming consoles. So Sentry is trying to cover most of the potential platforms and help basically every single developer who's developing games gather some data. But beside games, as I mentioned, 100 plus SDKs, so back and front end, server code, Sentry helps you monitor it all.
One of the things that I ran into so it's like I'm looking at games and I'm looking at game crashing and there's like all kinds of Windows stuff. There's a lot of noise. And one of the things that helped me cut through the noise that Sentry was specifically useful for was one of the game developers had implemented it on their back end. And that was the thing that was like, oh, there's something really nice here because their game backend they'd optimized. There's no Unreal Engine, there's no on their backend. Their backend was just a really lightweight like API layer, and it was absurdly fast, low latency, and they'd actually put hooks in their system so that they could see, what was going on in terms of player count, and there was some cheating, some anti-cheat stuff in there that they could log with Sentry, and that really helped me get to the bottom of what I was working on because it was server side crashing, and so that's something I think that people should understand. Is like, oh, it's not just something for games. You can actually holistically see what's going on in the game client as well as the server simultaneously and have that logged in one place.
Yeah, correct. So especially for the live service games where you have client server architecture, as you just mentioned, distributed tracing is something that Sentry offers, and it basically helps you connect the dots between what player is doing in their game and when playing the game and what server is doing. A simple example is, I'm a player. I want to buy something new, want to buy an upgrade. I want to buy some new item. Usually, the game client will send some requests to the server. Server will need to process these requests, do database queries, all of the nice backend server stuff, and then give an answer to the game client. And what Sentry helps game developers and in general developers do is, connect this trace, distribute the trace, and track every single step and data from the client all the way through to the HTTP and or any other layer to the server, to the database, and all the way back. So basically, whenever we have problems like, a player clicked on a button, it took 3 seconds for whatever reason for a response to come back.
In my case, it was we didn't even know the thing that we needed to be logging, and so it was like a little bit of like sleuthing. Is it was like, why is this crashing? Like, why does this register contain this value? And if you look at some of the breakdown of like I think it was Oodle on the Epic side. It's like they were looking at like how the decompression algorithm was failing, and it's like, well, this code hasn't changed in 20 years. Something interesting is going on there. But what melted my brain was the fidelity, and you guys have built a nice user interface around making it easy to not just get at the data, but also build custom queries and logs, and when you're really trying to figure something out that's complicated.
The Sentry as a platform helps you gather data, helps you filter data, helps you identify the hotspots, but also gather some data that could be useful in investigations like this. For example, data about the device, data about the GPU version, CPU, driver versions, and all of the other metadata that could potentially help connect some issues other to the other things outside of the code and the software. But yeah, also helps you monitor your performance and making sure to say it's the same code, it works nicely, it performs nicely everywhere, we're not getting any performance errors. So where do we start looking at right now?
Now, you can also add, like the facility is not just logging and data from within your own code. You can also get a lot of information about the underlying platform and the operating system, and like Windows event log, or Linux logs, because in this case it was Linux servers and the Windows client, and so it was really sort of, there's a lot of functionality there that goes beyond logging platform.
Yeah, correct. So Sentry is trying to give you all of the data that you could possibly need. So looking at the front end, for example, or in this case, looking at the game, stack traces and screenshots, it's probably something that most of the game developers like, seeing what was happening in the game. But when we are talking about the backend and the other side of things, it's server Linux logs, as you said, and different kind of attachments and everything else that you can insert and enrich your Sentry events with. So yes, we're trying to be a one-stop shop for all of potential data sources that you would need.
So, I mean, that the Intel thing, that was a once in a lifetime event. But bugs are common, and bugs happen, and there are things that are a lot more common. I remember one of the first times that I thought I had found a smoking gun. I was looking in the client, and it was a decompression error. And I was like, oh, I found a decompression error. And I looked, and Sentry had actually logged something, I think, from the Windows event log for this particular game client, or I don't remember the details, but I found something that let me trace it to the Windows event log, and the error in the Windows event log was like, NVMe timeout error or something. And I was like, oh, well, that's why it can't decompress the texture. It can't read from the NVMe. This is probably not CPU related, and like driver timeouts and stuff like that. Like you guys have a lot of clients where you've been able to work through those issues as well. So can you talk a little bit about how it can help you troubleshoot like black screens or unexpected game behavior?
Yeah, of course. Besides stack traces, I think it's something that we already mentioned, and something that every software developer likes. Sentry provides you way more tools, to track what was happening. For example, I will take an example of breadcrumbs. So breadcrumbs is something that, as the name says, as a developer, you can be placing your breadcrumbs inside of your code. So whenever an issue happens, you can basically follow your breadcrumbs all the way down to where the issue started. Let's imagine, you have a tower defense game and you buy some upgrade, and you click on a button, and for whatever reason the game crashes, right? And you would, as a user, you would go and say, hey developer, I pressed this button and your game crashes. And I, as a developer, would go and say, okay, what's wrong with my button? But maybe it's not the button, maybe something deeper is going on. And that's exactly what Sentry is built to do. It's to discover the bugs that are not easily discoverable without the amount of data and additional data and the metadata that Sentry events provide. It's also something that is probably very hard to discover without the additional data and without the amount of data that Sentry can provide you.
Now, you guys have a like a really amazing example project, a tower defense project that shows how to integrate Sentry into a game. Which is, if you're a game developer or a game developer student, and you're, like you're an indie developer, I think this is a project that's worth taking a close look at.
Yeah, exactly. So the demo project, I think I already teased it up in the few of the previous sentences, but we try to show some of the basic pitfalls that the developers, the game developers especially, can face. From blocking main thread due to the HTTP requests that are being processed very slowly on the back end, and then showing the distributed tracing from game to the server and back with the spans, which is basically a granular view of timing data across different functions and services, up to, as I said, crashes that are both CPU and GPU crashes that usually, you know, at the first look will not show you what the problem is, but with all of the additional data, I think the life of a developer becomes way easier. And with life of developer becoming easier, it means they can fix problems faster, which means that the end user can have a better experience faster. So I think the project, the Sentry Tower project, as I said, is one of the demo projects. We have it for all of the engines. We have a demo project for Unity too, where we're trying to show similar pitfalls with Unity. But I think it's a great place to start looking at if for game developers and seeing how to integrate Sentry into their game. Yeah,
Okay, so we're looking at the tower defense game, and we're playing tower defense, and this is great. And I can download this and run this. It's not a big deal. But
right.
what does it look like on the back end? That's this web interface. You got, there's a graph here. There's all sorts of there's a lot happening on this interface. What is this? Okay, exception access violation, or okay, so I've done something bad with memory. I know what that is.
Yeah, correct. So that's also my question, right? What's wrong here? What is this exception violation, right? But I think the first interesting thing here is, even without looking at specific issue, that this view um, already helps us a lot, because on the right we can see the trend, we can see the number of events and number of users that are affected by it. And just looking at this first page, I can tell you, yeah, well, we have two issues that are happening a lot. We have three issues that happened once or twice. So yeah, I think probably what we should look at first is the exception access violation, right? Because it happened 42 times, it's ongoing, it's happening all the time, and it's already 2 months old. So maybe it's time to fix this one in our game, right?
So in other words, the dashboard is already helping you figure out, which people might have a malfunctioning something and which people might have, something else. I found that in the data too. It's like, let me just see all the errors, and there were a lot of people with laptops that were suffering greatly trying to play games on laptops.
But
So
yeah, let's
this is
see
great.
what this is helping us already. So now that we decided that this is probably the most interesting issue to take a look at because it's happening all the time, I think we can go into the issue and actually see how it looks from the inside.
So I'm looking at this screen. With the timing here, and I think I understand what's happening. It's like a lot of stuff that you run into in a game is timing based. It's like if you did this sequence of actions, that's what leads to the bug, and that is very, very hard to debug. And so you guys have built an interface here to show the last sequence of things that led up to the event. Now, some of this is on the developer to implement, obviously, but I like the interface here because it's made to make the developer time spent on this as little as possible.
Yeah, correct. So I think looking at the event already from the first look, me as a developer, I would start looking at the red things, right? So, and we have a lot of red things here. And looking at the top level span, so the HTTP client checkout span, we can see that something took 697 milliseconds. which maybe is not a lot when we think about time, but when we think about everything that we like in the games is having big FPS numbers, right? Just imagine having 1 FPS for a second because an HTTP client did something for almost a second, right? So this is exactly what we are helping you to discover here. So we can see that we are sending some HTTP request, which is already taking quite some time. So probably maybe we should also take a look at our front end client. But I think what's more interesting here is, which as we mentioned up until now, is distributed tracing. We see that this request went to an HTTP server that's running on Flask, and then if we expand the HTTP server span, we can see actually what the server was doing. As you said, that's exactly what you saw in one of the issues that you were looking at. So we can see exactly which functions were called on the server side. We can see that we wanted to execute a database query. We can see what the database query was. And we can see actually that the server was pretty fast, right? It didn't take that much time for the server to get back to us with the response. But for whatever reason, when we got that response, it took us almost 400 milliseconds to process it. So now, as a developer, I would probably start looking at the longest red line that I have here, and that's going to be processing the checkout response.
It's nice because you can see the front and back end state for everything that happened between this, and it works really well. A lot of the time, that front end code like this, you get down to it, and it's like, oh, this is some misimplementation of a finite state machine, and it's like, oh, developers need to learn more about finite state machines. But then you look at this, and it's like, no, this is really just an interaction between, a server client and like the transport. Sometimes the network connection just takes a long time.
And I think this is also where the newest addition to the Sentry features, the Sentry logs, come into place. If you look at the logs in the issues in the issue in the issue itself, we can see some logs that are coming from the server side that are actually telling us what the server is doing. We received the checkout endpoint request, we are processing it, and then at some point, we failed to validate the inventory with the cart with a lot of additional metadata in there. So this is the Sentry's take on logs. We know logs from everywhere, but we are trying to connect these logs to the events that you're looking at. So basically, this saves you a lot of time trying to debug, what the server did, what was the response, by looking at the same issue. And that's what we said. We are trying to give you as much data as we can in the issue itself, so you don't need to go around on the crusade of finding the logs. We try to put it in here if you opt in to use the logs feature too.
I think it's also interesting, if we talk about like the life cycle of dealing with these kind of bugs, you've got full integration on the whole DevOps side of things, not just with GitHub, also Azure, also GitLab, also if you're going to host your own stuff. I see, Jira integration and other integrations, probably custom webhooks if you want. And so it's like, here's the issue on GitHub, here's the code that we committed to fix this, and then here is the history and the problems that people experienced that led to these changes. Because it's like, I'm going to push a change, it's like, oh, now I have new and different errors and a lot more.
Yeah, correct. So we all love Git bisect, right? Trying to find a commit that caused an issue. So Sentry is taking another look at it, and basically, if you integrate fully with Sentry, we can track your releases, we can track commits in your releases, and then also try to help you, pinpoint because we know when the first time that your issue came in, we know when you deploy the new release, we know which release your clients are running, because we have all of this metadata. So with all of this information, trying to pinpoint where the issue came from and Git blaming someone for it should be way easier.
Git blame is amazing.
Yeah.
I love that this is also a complete project. It's like we talked about, you can check out this from GitHub, but if you're a student and you're interested in game development, you can check out the entire project And this is much more of a real world project, I think, than some of the other tutorial projects that you might find elsewhere, because that kind of, ops integration and like closing the loop on fixing the bugs and doing the development and having the telemetry about the bugs, or having the software data about where the bugs come from, um, is much more realistic and a much more real world experience for people that are learning about, it's like, I want to be an indie dev. And it's like, you start with this project because it's got a lot of real world stuff in it.
Yeah, yeah, I agree. And I think, Sentry is free to try. Our demo is free to download. I think it's enabling everyone to go out and try it out. And I think integrating Sentry early into the indie games, but in general into all gaming projects, I think will in long term save you quite some time, making your game more stable and getting to the quality that every game dev aspires to have.
All right, so those are crashes actually inside a game, but I wanted to show the audience, everybody that's watching, how Sentry can also crash or detect crashes that are not necessarily game related, maybe game adjacent. And so you helped put together this demo, which crashes in some other interesting ways, and what that looks like. Can you walk us through that?
Yeah, of course. So we discussed the basic crashes that we all are used to seeing, but I think the next level of debugging crashes it debugging GPU crashes, and I think one of the most interesting things when it comes to GPU crashes is usually for the user and also in the error log, it would just look like the GPU disappeared. The device was removed, the GPU went down,
Black
and the
screen.
reason the black screen, yes, and the reason for it is the way how Windows integrates with your GPU, right? If your GPU is doing something that it shouldn't, or it's taking too long time, the TDR, the timeout detection and recovery, is going to reset your GPU driver. And how it's going to look for the game is, hey, your GPU disappeared, so now you get the black screen from me.
There's a lot of
And
people in the audience that is like, oh, there's the Windows Event Viewer, and it's like, yes, Windows Event Viewer will have a lot of really useful, interesting stuff in it. And sometimes your game needs to be able to read the Windows event logs, because Windows doesn't really tell your game exactly that the GPU crashed. It's just the GPU's not there for a second.
correct. And then I think if we go and look at the event viewer, we can see exactly what happened. I mean, exactly what happened. We can see that the error occurred on the GPU ID with a specific ID. We can see which video device it was, and we can look at some details. But this is not something that per default the game developer is going to get if this happens on a user PC. You're at the grace of the user to send you something like this. And B, even looking into this, it's probably not going to be the easiest way around on figuring out quickly what the problem is, right? So at Sentry, we are trying to simplify your life for all of the crashes, CPU, GPU included. So if we compare now the event viewer from this GPU crash that we just simulated with how the Sentry event looks like, we can already see that we are seeing way more information in there. We can see a lot of the metadata. First of all, starting with your GPU version and the driver version, which is probably something that's very important.
There
Um,
are bad versions of things.
there are bad versions of things, but also, looking at the full stack trace and the trace on the GPU. For example, we can see the event or the error that happened, which is, in this case, error device hang. So, your GPU stopped responding, which is again not that helpful. But if we go on, we can see exactly what the GPU was doing at that time, what the computational pipelines were doing, which shaders we were trying to run, and also we can include a lot of the information from the manufacturer SDKs, like the aftermath SDK from NVIDIA, which can tell us a little bit more about what the GPU was doing, and also provide you with a very useful GPU dump that you can take a look at. But beside that, some other metadata, like this is the amount of total memory that the GPU has, this is the amount of memory that was used, this is the budget, and trying to to help you distinguish between, okay, did my game do something really wrong, or did the GPU do something wrong, or did the Windows do something wrong, or the operating system in general?
I like the SDK demo for introducing developers to these kinds of things because they don't always think outside the box. I pulled some logs from some of the systems that I was working on, and there was a really interesting pattern that was emerged because it's like in a pool of game servers, some of them had been configured to never go to sleep, and some of them had been configured with default power management. And so the ones that had been crashing with default power management that had since had power management disabled were stable again. Whereas the ones that had power management off the whole time, they were running at full speed the whole time, were still unstable. And then it's like, okay, well, the ones that had power management disabled that were previously enabled, will those eventually become unstable? And the answer was yes, because degradation was occurring. And so it's like teasing out all of those variables from this huge stream of data is just, it's insane. It will make you go crazy.
Correct, but just imagine trying to do it without data.
So this is all amazing in terms of, data and telemetry and stuff, but it also occurs to me that like we could use this on the console side of things. And you guys have rolled out support for this all the way down to the console level because some of it is performance related and some of it is actually debugging related because it's not just enough that everything runs fine. If you're going to run fine but be 2 FPS in sort of a console scenario, and so you guys are now doing analytics as well as this kind of debugging. So walk me through that. Walk me through the console parts.
Yeah, correct. So I think we want to get Sentry to every single developer, and we want to help everyone. And beginning of this month, we actually had a GA for all of our console SDKs. So for PlayStation, Xbox, and Nintendo Switch. Um, and as you could imagine, developing for the consoles versus developing for the PC or mobile is a completely different scenario. First of all, starting with dev kits, availability of dev kits, testing your games on dev kits, versus having just a PC built to test out your game that you're building is already a first hoop. And we are also trying to help you there. So we are trying to provide you with the tools that you can run on dev kits, provide you with the tools that you can run in production. So what the goal is, and what the goal was, and that's actually what we GA'd, is to be able to, as simply as it is for all of the native games on PC and mobile, so that in the similar way you can do it on console. And I think console is a bit different scenario where you will not have 10,000 different variations of GPU and driver versions and so on, because it's quite controlled, right? It's all of the same hardware. But optimizing for consoles for all of the use cases and scenarios is probably way harder, for the challenges that we just mentioned.
It's wild to me because I see so many like smaller development studios and indie development studios really putting in the work to really chase down all these, like they run the tools, they run Sentry and tools like Sentry to be able to monitor the performance. And you see the web interface there, you see how easy it is for a developer to look at them and be like, oh, there's 600 milliseconds of timing here, or this particular timing graph, maybe people are not having a good experience in this way or that way.
So no matter if you are a very experienced developer or just starting to develop, I think the Unreal Tower and in general all of our demos and SDKs will help you start with it quite easily. Maybe not with consoles, but starting easily with the demos and then moving on to consoles. But outside of the gaming world, Sentry offers you a large variety of SDKs for all of the most popular development languages and tools that folks are using these days. So, looking at all of the SDKs that Sentry can offer you, and just trying to run them locally with few lines of codes, it should not be harder than that. I think is a great place to start.
Yeah, web apps even. It's like, oh, I've got a WebAssembly application with something. It's like, yeah, you got a JavaScript SDK. It's you can get it done. It's pretty amazing. So basically, anything that you're building is good to go. And I know there's a lot of game dev students and indie studio, like small studio, like 1 to 5 people. This platform is so well documented and well put together that it is entirely usable, even for single developer operations, even for students. I wouldn't be surprised if professors start trying to integrate this into their curriculum just so they can see what students are working on from the professor's Sentry dashboard. Sentry's given me a promo code. You can use promo code Level One Text and get 3 months of the free team plan. And so that's Sentry for game developers. You should definitely check that out. Download from GitHub, try the test projects and all that. Thank you again, Amir, for joining me, because Sentry was instrumental, pun intended there again, in helping me figure out and gather the data and knowing which knobs and levers to pull as I was doing the CPU degradation issue. So again, thank you very much. I'm pleased as punch that you guys sponsored this video too, because you know that investigation took a long time and a lot of money. So yay, thank you. But also it's a good product and I actually used it and it made my suffering less, which was great for me. So thanks very much.
Yeah, thank you for having me here, and thank you for this nice context switch for me, from coding to the videos, pun intended, as you would say.
Yeah, context switch, yeah. There's not been an integer overflow. There's everything's
No,
what
no
it should be in the
overflows,
registers.
no overflows. Everything is great.
All right, well, so you know what to do. You wanna go download Sentry on GitHub, check out those projects, and start building your indie game today. Now is the time. Maybe you're fun employed. Now's the time.